Now you may ask, what is a logistics system? Okay, so a logistics system in hard way is very complicated, but in simple way, it's just about moving things. The things moved can be either products or goods, or even human beings. So let's consider cases about why do we need to move things. So let's see if we have a point A, and then this point is at Wisconsin. And we have another point B. Let's see, this point is at Illinois. So the people at point A, let's see, every day they eat corn and then they drink milk. Similarly, at point B, people also eat corn, just for example, and they also drink milk. So if the corn and the milk are produced at each point by their own, right? So the people at point A grow corn and get milk by themselves, and then they feed themselves. And people at point B, they also grow corn and they raise cows to get the milk. So there's no need to move anything. But someday, people at A and people at B, they met together, and then they happen to find out that the corn at location A, so the corn at location A, comparing that with the corn at location B, people think the corn at location B is more delicious. And also, the people from B think that the milk at location A is more delicious. This may be due to many reasons, like the soil, like the cow, and then like the weather conditions. So many factors affect that the corn and the milk produced at different places, they are totally different. So after this observation, people think that they should grow corn at location B. And then they don't like their own milk. They like the milk from location A. And similarly, the people at location A, they do not want to eat their own corn, and then they want to eat the corn from location B. So under these scenarios, now the milk produced at location A need to be transported to location B. And also the corn produced at location B need to be transported to location A. Okay, so we can see the need for transportation or moving things. Although this is a very simple case, but this tells us why we need logistics system. Because in general, people will produce different products at different locations, but then their demand may be at some other locations. So we need to move things from where they are produced to where they are consumed. That is why we have a logistic system. You may think the previous example is very simple because it has only 2 points and then 2 product. Okay, so A generates the milk, produce the milk, and then ship it to B. And then B produce corn. And then A consume it. Although this looks easy because it's just a 2x2 matrix, but it still involves multiple the supplier or producer and multiple consumers. So let's make it even simpler. Let's just consider one product, for example, milk. Let's see, we just consider location A, want to provide milk to location B. Okay, this is a simplest case, right? We only have 2 points. 1 point is the producer, and 1 point is the consumer. Sometimes we call this structure one-to-one system. Okay, so there are also cases. For example, let's see if we have point A, still in Wisconsin. And then let's see customer or consumer B said that the milk is really delicious. So every people around US, they like the milk produced by Wisconsin. So that means we have multiple consumers. Let's see, B1, B2, have multiple consumers, Bn. Okay, so the question is, how can we ship our product, our milk, to multiple customers? So we have called one-to-many system. Okay, so definitely we can have multiple producers. A1, A2, AM, and then we want to ship to multiple producers, customers. Then this are very complicated. So many arrows. Yeah, this is many to many. So we can see as the problem becomes more complicated, there are a lot of decisions to be made. So typically, our class will cover simple cases where the one-to-one system or the one-to-many system. So if we have enough time, we will briefly mention some simplified cases for many-to-many system, because in general, many-to-many systems are too complicated, involving so many decisions, which are hard to address in this class. You may wonder why shipping from point A to point B, just one product, is kind of a problem. Okay, so the issue for the transportation is not about the transportation itself, it's about the cost. Okay, so for example, if you produce milk at point A, let's say 1 gallon per day. So every day you get 1 gallon, right? And then you want to ship it to location B. Let's see if you just ship it every day, okay? So you send a truck. Okay, to ship it every day. So that means every day you need to send a truck. So the transportation cost is kind of high. You may heard of a terminology called economic of scale. What does that mean? It means that you do not ship the milk every day, okay? You ship the milk, let's see, every week. So that means day 1, day 2, until day 7. You accumulate 7-gallon milk, right? After you have 7 gallons, right? You use a bigger truck, right? There are 7-gallon milk. Ship it to B. Okay, so that means you can ship the milk by just 1 truck every week. So if the cost to rent a truck or dispatch a truck per week is cheaper than to send truck 7 days every week, so typically that's the case, right? Then that indicates you saved a lot of transportation costs, right? So your transportation cost significantly reduced. Okay, so definitely if you want to accumulate more milk that will save you more money in transportation, then you may incur another issue that your milk produced by location A can get bad. So that means you may not need, or you may not be available to produce the milk and then store them for longer time. Let's say if you store them for 1 month, okay? If you store them for 1 month, then you may have 30 gallons per month. But then in this case, your milk will become bad. You may throw a lot of milk for garbage. That's not good, right? So that indicates you have inventory cost. Okay, so typically for a logistic problem, you will balance transportation cost and inventory cost to reach a good balance. Okay, so that means you may not have 30 days, let's see, some kind of a specific date. So this decision, a best trade-off between time and between locations. So this is a very typical decision problem for one-to-one systems. So we will discuss this. This is kind of like inventory management problem. Now for one-to-many systems, you have one point A, and then you want to ship them to multiple points B1, B2 to Bn. Okay, so this is definitely we also can observe some economic of scale problem. The worst case, you just dispatch trucks to every locations separately. So in this case, you will have a lot of transportation cost because there's no economic of scale. So one simple way to do this is to have a big truck and then just ship once. Okay, so you can just ship from A, go to B1, B2 to Bn, and then go back. So in this way, you just have only one truck, right? So here you have n truck. Now you have only one truck. So you see a similar economic of scale property, right? So under this case, you saved a lot of transportation cost. However, the issue is that for the majority of time, you may have capacity issues, right? So the truck may not be big enough. So that means you may only have certain amount of destinations covered by one truck. Then in this case, you have to split all your destinations or your customers into different groups. So in this case, you may have one truck serve some of the destinations and go back, send another truck, and then go back, blah, 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 right? So you may have different groups, right? So this is one group, this is two group, and then you may have different groups. So this is a typical problem. We call this vehicle routing problem. Okay, so a simple realization of the vehicle routing problem, we call it traveling salesman problem. Consider just you have only one vehicle, one truck, and then ship all of the products one by one. Although you only have one truck, the issue is what is the order that can reduce the transportation cost the most, right? So you just find all possible combinations. You can see there are n plus 1 point. So there are n plus 1 points. And then for each of the destination from B1 to B2 or from B1 to B3, you have a lot of choices. So this is a combinatorial problem, and it's a very well-known, call it NP complete problem. So that indicates it's hard to solve as the problem scale becomes large. This is a exponential or combinatorial problems. So we can only solve the problem scale in a moderate size, even with the most advanced algorithms. So you can see how difficult this type of problem can be. Another aspect of this logistics problem is that when you transport something from point to point, you may find out an intermediate location as a buffer. For example, we can store some product in a local store and then wait for customer to pick it up. So in this case, that means the transportation can be decomposed into multiple stages. This is like producer, and this is consumer. And sometimes in the middle, we can have some intermediate facilities. So this brings us another type of problem. We call it a facility location problem. So this is also a trade-off between the transportation cost and then the facility cost. For example, let's see if we have multiple customers. Let's see, they are all B1, B2, B3, B4, B5, B6. And then let's say you want to build 2 facilities to serve them. From our eyes, we can try to configure that maybe we can build 1 facility here and then 1 facility here. So that means these 3 customers can go to facility 1. Let's see, this is F1. And then these 3 customers can go to this facility 2. So definitely you can see if B3 goes to this facility F1 rather than F2, this transportation cost, this is big, right? This cost is high. Comparing with this, right? If you compare this with this. So the customer should choose the shortest distance. Okay, so then this inspires us, how should we choose the facilities, right? How should you find out the best location that balance the distance to the customers and also the number of facilities? The smaller of the facilities, right? You can see if we have more facilities, each facility we will have a installation cost or maintaining cost. So this is typically huge. On the other hand, the more facility you build, the less of the transportation distance closer to your customer, right? So this is a transportation cost. So the facility location problem is type of problem trying to balance these 2 costs and then find the optimum point.